Hello, lovely viewers. Good morning, depending on where you are, or afternoon or evening. I want to welcome you once again to this video on technical drawing with Teacher Dixon. And in our today's lesson, we want to continue on special curves when it comes to technical drawing. We've already had a kind of lesson on this, the introductory part of it. But today we want to focus on ellipse. All right, this is one of the special curves when it comes to technical drawing. And we want to see how to produce, at least we should be able to produce one today. Afterwards, we'll go to other methods. So in our today's lesson, we are having ellipse, like I've said already. Now, what is an ellipse? An ellipse is a plane figure bounded by a curved line called the circumference. So just like a circle, an ellipse is equally a plane figure bounded by a curved surface, which is called the circumference. Now, another definition says that it is a plane figure in which the sum of the distances from any point on the curve to two fixed points called foci is constant. Now, we are going to, when I start the drawing, you will see these 2 points that we are mentioning, which are called foci. Now, that's the plural form of focus. All right. So, in essence, we are having focus point, or you call it focal point. So, in an ellipse, we have that. So, when we have a curved line that has this foci, we refer to it, a curved shape or plane figure, we refer to it as an ellipse. We're going to show the diagram. All right. In an ellipse, we have what we call the parts. So, just like a circle, that we have the circumference, the diameter, the radius, the chord, and so on. In an ellipse, we also have the parts, and one of the parts is the major axis. The major axis. And we have the minor axis, we have the center, and the foci. All right, let me just show us a little of this. All right, an ellipse looks much like an oval shape. Permit my drawing. This is a freehand sketch. When I'm going to do the reconstruction, we're going to get it right. Okay, so it looks somewhat like this. Okay, so the major axis is the longest diameter. So if I have a diameter, the longest part, when you divide the ellipse into two, it is called the major axis. While the minor axis is the shortest distance, shortest diameter rather, right? So this is the shortest, this is the longest. So we can refer to this as the major axis while referring to this as the minor axis. All right, and then this point of intersection between the two axes is what we call the center, as you've seen here. Now, I will not want to point so that I will not mistaken where we call the focus or the foci when it has to do with two. I won't want to point that, but in the drawing, when we are facing the real construction, I'm going to point them out, the two foci. All right. So after which we might have done the part, we want to take a look at the usefulness of ellipse in technical drawing. So I draw your attention to this side of the board. All right. What do we use this ellipse for in technical drawing? Do we just draw an ellipse? What's the usefulness? Now, number one is that we use it to draw isometric circles. We use it to draw isometric circle. Now, let me try to sketch an object to tell us more on what we call that. So if you have a front elevation of an object like this, and this is a two-dimensional shape, right? And you're asked to represent this. And remember that this place is like a tube. You're asked to represent this using isometric. The shape might look somewhat like this. I might not be so precise. I'm trying to illustrate something, right? It looks somewhat like this. Okay, then you have, let's assume that this face was towards this side. Okay, so you have the face come like this. Now, this will show us an elliptical shape at this point, not a circle. But here, if you have maybe the plan, is it the end view of this shape could have been like this. So you're having a circle here. But when you're drawing that same circle, using isometric, it turns to an ellipse. So that's why we say that in technical drawing, we use ellipse to draw isometric circle. So this shows us an isometric circle as the part of the tube. All right, number two, we say an ellipse is used for drawing of pipes and cylinder. We already know what a cylinder is and a pipe, a common material in use in the society, a pipe, like what you use in your sockaway and so on. All right, we say number three, it is used in mechanical and engineering designs. Right? We'll talk more on this as we go to assembly drawings and maybe isometric and so on. Also, number 4, it is used in architectural drawing, the drawing of plans, design of building, construction plans, and so on, blueprints. Number 5, it is used in automobile and machine parts. It is equally used in automobile and machine parts. When we talk about automobile, if you look at a car exhaust, I think you will have a pipe. If you look at other parts of the car and other vehicles, I believe you will have where we have elliptical shapes. Okay, so that is what we're saying. And other machines can be engine, soundproof, and so on. Okay, now we want to take a look at the methods of constructing an ellipse. You know, we are supposed to dwell on this. This is a practical oriented subject. So we are going to do more on this. We'll get to our drawing board and proceed in having the full view. I hope this is where your attention should be drawn to. Okay, the first one is called rectangular or oblong method. That is the one we will start. In this video, we are going to present this one right away. Okay, number 2 is auxiliary circle method. I think maybe after this one, we will put that into practical. We have equally triangle method. This is the real practical method of which we're going to carve a triangle and use to construct. All right, so the 3 we're going to consider. We have more, but I want to dwell on this because of the level of students I'm expecting in this video. All right, so let's stay tuned while I take you on the rectangle or the oblong method. Stay tuned. Let's go to our drawing board. I'm your teacher, Teacher Dixon. Thank you. Please wait as we go to the practical stage. Let's get into business. So to begin with, we have to draw the rectangle. And I will want to take the length of the rectangle to be 120 mm. So I first of all start by drawing a straight horizontal line and then fix a point. So that point shows the beginning. And then I will count 120, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 120 mm. And then I will want to take my vertical, and that is the breadth to be 80 mm. So I'll first of all draw a vertical line at this point. And also with the use of my set square, I draw another vertical line here. Having drawn that, I will take the measurement using my ruler. Remember I said 80. So 1, 2, 3, 4, 5, 6, 7, 8, which is 8 cm. That's 80 mm. So at that point, I draw my upper horizontal line. All right, that has given me a squared rectangle. Now I am to bisect or divide a rectangle into 2 equal parts on both the major and the minor axis of the ellipse we are intending to draw. Right, so 120 divided by 2 will give us 60, and then we have at this point, and 80 divided by 2 will give us 40. So let's see, we have here 1, 2, 3, and 4. So I fix the point here. Now I work with my T-square and set square. The T-square draws horizontal lines, so I have this drawn already, and the set square alongside with the T-square will give us the vertical line, which make the vertical, the major and the minor axis. So we want to name the sides at once. So I start by calling this A, and I call this B, call this C, and this D. While I decide to call this my E, call this my F, call this my G, and this my H. All right. So I have drawn the vertical and the vertical and horizontal line to divide the rectangle, thereby giving me the major and the minor axis. All right. Now the next thing I will do is to divide each of these faces into 4 equal parts. So I first of all do my calculation. Even this and this we divide into 4. Now how do I do that? I do my calculation. If this was 80 divided by 2 give me 40, means 40 divide by 4 will give me 10. This is 40 now. 40 divided by 2 has given me 20 each side. I take that again. 80 divided by 2 gives me 40. Now 40 divided by 4 will give me 10. So I'm going to use 10 units on that axis. So now I do this. 1, 2, 3, and then this makes the 4th. Now I have 1, 2, 3, and this is the 4th. I do the same thing on this other side. I have here 1, I have here 2, 3, and then this 4. I have here 1, 2, 3, and 4. All right. So that makes up the vertical line. Now I go to the horizontal. This was 120 mm. Now for me to divide it, I'd already gotten 120. 60. So 60 divided by 4 will give me 15 each. So this is 1, 2, 3, and then 4. I go the same way here. 1, 2, 3, and then 4. All right. So gotten that. Now the next thing to do will be for me to radial lines to meet each of the points. Okay, let me first of all number. So I begin here with 1, 2, 3, and this gives me 4. So 3, 2, 1. All right. Now here I have 3, 2, 1. I have here 1, 2, 3. I have here 1, 2, 3. I have here 3, 2, 1. All right, so I finished that. Now I'm going to radiate lines like this, this, and this to start making my ellipse. So let's see how that goes. So that means 1, ensuring that it is at the exact point of intersection. Right, now I come down to make the same thing using my ruler now. Result for the t-square and z-square for now. All right, so I now go to the right hand side as well. First line to 1. Right. Okay, now the next thing I'm going to do is I'm radiating. Remember, this is 1, 2, 3. So the next one I will make it to pass through this point 3 to meet these other 3. Right? So that is what I'm going to do right now. So let's just say 3 to 3, 4 to 4, 2 to 2, like that. So let's see how that will be gotten. Look at my point 3 here. Let me make it clear. So I start from still the axis, I radiate to 3. So that is from 3 to 3. Next thing to be done, I will radiate 2 to 2. That's point 2. I start, begin from here, pass through 2, touch 2. Now 1 to 1, look at 1 here. So I radiate that, passing through 1 to meet 1. Okay, now I will do that to this other side as well. 3, passing through 3 to 3. Getting the exact point is very, very important. So that is 3 to 3. Next will be 2 to 2. That's 2 to 2, and the last will be 1 to 1. Right, that's 1 to 1. Okay, so I come to this other side, start with 3 to 3. That's 3 to 3, 2 to 2, 2 through 2. I put it that way. So that's 2 through 2, 1 through 1 as the next. That is 1 through 1. Now I go this other direction. 3 to 3 first. 3 through 3, rather. Right, that is 3 through 3. Now 2 through 2. 3 through 2 to 2. And then 1 through 1 to 1. Okay, now at this point we finish. It's for us to make our curve to give us the elliptical shape we were asked to do. So at this point I'm going to use my French curve to get the points. So this is my French curve, so as to get it real and accurate. I'm going to look for the curve that matches the points very well. I'm going to look for the curve that matches the points very well. Okay, I think this will do. So I'm matching these at once.
Jeez, CF is good.
No, I'm not. Alright, so I've just started that. Onto this other side using the same. Okay, now having done that, I proceed with other ones, other points. Look at the point here, look at another one here. So I decide to use this corner. That doesn't match very well, so I look for another alternative. Okay, I think that does. So I draw to this. Now when you're making the curve short, at least you take them 3, 3 at once. So that's what I've just done there. I go to this other side.
oh, can I do that?
Is it your phone? Hmm?
Oh, wow.
Looking for a perfect curve there. Right, so that in a way matches it. Okay, now having done that, I've made a huge mistake at that point, but then all right, so that's it. Proceed to this other side. Right, still in progress. Right. Okay, so I have this. All right, now that gives me the ellipse I was looking for. Might not have been the perfect curve as expected, but that's somewhat what we expected to have. All right, so that's the elliptical shape. That's how it is done when you are using rectangular format to produce. Okay.